Okay, so if you're watching this video, hopefully you've installed Lean and everything you need, Git Bash, Python, VS Code, etc. And you're wondering how to create a Lean project so you can do some Lean yourself, or follow along with our blog post on ExLean, or do whatever you like. So so first off, open up Git Bash and make sure you're in the right directory. So you can check the directory you're in with this pwd command. And if you want to change the directory, just write cd, which literally stands for change directory, and then the address of where you want to put your Lean project. So let's get stuck in. So we're going to use a program called Lean project, and we want to create a new one, so new, and then now we just put in the name of the project. What do we want to call it? So I'll call mine test_project. Now that will go ahead and download a copy of mathlib and some other things that you need. That should take a second. So now that's all done, we can go ahead and open our project by writing code and then the name of our project. I called mine test project, and that should open up VS Code for us. Here we are, and this source file is where all of our, this source folder, should I say, is where all our Lean files will go. So we can go right click, new file, test.lean. Now also, I'd just like to mention quickly, in this folder is where mathlib lives, and you can see all of the wonderful mathematics that has already been formalized here. Okay, so let's just import some theory about real numbers, so we can prove something quickly. Okay, give Lean a second. Sometimes my computer is a little bit slow. There we go. Okay, so we're all ready to go. Let's just do a really easy example. So let's just say we have three real numbers, A, B, C. And let's just do something really easy. So okay, so we just want to show that these two expressions are equal. Well, it's quite easy to see that they're equal, but it's not so easy for Lean to see. So let's try and explain why they're equal to Lean. Okay, so well, if we look over here, just a quick thing to note is that Lean always omits the first bracket. So there's an imaginary bracket around the C times B there. So we're just going to go ahead and use the commutativity property of multiplication over real numbers. So C times B is the same as B times C. And this is how we tell Lean that, and we want to apply it to C and B. And now we've got B times C, there's the imaginary bracket, times A. So now we actually want the brackets around the A and the C, so we're going to use associativity. BCA. And there we go. And now all that's left is just to switch the C and the A around to make both sides equal. So that's commutativity again. And that's our first proof done. So now we've opened a project and done a proof. Now, just before the end of this video, I just want to mention a couple of really good resources to get to grips with Lean. So open up Git Bash again, and we'll just open them up. So now we go Lean project. So this is going to be the tutorials project. So Lean project get tutorials. This is a great start to get to grips with the basics of Lean. And of course, I also recommend our ExLean blog and this YouTube channel. And all the information about these resources will be in the comments. There'll be a link to the Lean community website where you can see all these instructions in text. So let's just go ahead and open tutorials. Here we are. Let's open up the source file there, and we can see the exercises. Here we are, and yeah, it's a great way to get to grips. And these should look familiar. We did a similar one, but yeah, okay. And another resource I want to mention to you guys is mathematics in Lean. So Lean project get mathematics _in _Lean, and I'll go ahead and download everything again. And great, let's just open it up. Here we go, and click on welcome. And here it is. So you can follow along reading the book or PDF, however you want to call it, and you click try it on any of the examples, and it will literally bring it up here, and you can interact with them. And there's some nice exercises where you just replace the sorry with the proofs. Okay, thank you for listening. Hope that was useful.